All right, class, this is two videos or two concepts that you guys asked me for. You asked me to go through scientific notation with you, okay? And some people also asked me, for whatever reason, asked me about slope. Even though slope is in the next topic that we're talking about, I had a couple people to ask me about it, so I'm going to go ahead and address both of these questions in this particular video. With scientific notation, the whole purpose of scientific notation, the purpose of scientific notation is to write um, numbers that are extremely small and numbers that are extremely large to make them readable. So the purpose is to make small numbers or to make extremely small numbers or extreme small or large numbers readable. That's really the purpose of scientific notation, because sometimes a number can be so small that it's hard to even fit it on the paper. Let's just be clear. And sometimes a number can be so large that it takes up too much space. It's also hard to put on paper. So you're making those extremely small numbers and extremely large numbers readable. And this is what that form looks like, okay? All right. An example of what scientific notation looks like is this, is when you have a number. Well, let's start off by writing a number, a regular number in scientific notation. We won't use a big number. We'll use kind of a big number, okay? Mm, okay, so 53,482, okay? And remember, a comma is not the same as a decimal. Commas help us read numbers better, but it's not a decimal. So if you don't see a decimal in the number, the decimal is automatically behind this last number. Okay, so your first step is to locate the decimal. All right, so let's do our steps out to the side. Locate the decimal. Okay, the second step is to move the decimal behind the first significant digit. So we're going to move the decimal wherever that decimal is. We're going to move it behind the first significant digit. What is a significant digit, Ms. Reyes? Significant digits are digits that hold values 1 through 9. 0 is not a significant digit because it doesn't have a value. So we're going to take this decimal and move it behind the first significant digit that we read. The first digit that we read is the 5. So we're going to move the decimal behind the 5, okay? As we're moving the decimal, we're going to count the number of spaces. 1, 2, 3, 4. We move that decimal 4 spaces. So the third step is to rewrite that number, and you're automatically going to write times 10. Or, yeah, sorry. We use the base times 10 because 10 describes place value, okay? We use a base 10 to describe place value, okay? So we moved it. How many times did we move it again? We moved it 4 times. So we write the number as such. Oops, sorry, y'all. 5.3482, and we write times 10, and the exponent is going to be how many times we move the decimal. So for the exponent on the base 10, okay, the exponent will be how many times you move the decimal. Okay, you move the decimal 4 times, so the exponent is 4. Now, Ms. Reyes, how do you know if the exponent is going to be a positive or a negative? If the original number is bigger than 1, your exponent is positive. If the original number is less than 1, your exponent is negative. The original number was 53,000 and some change, so it was greater than 1. So that's why my exponent is a positive. And this number is written in scientific notation. So I'm going to make a star here and write this down. If the original number is greater than 1, the exponent is positive. Okay? Another star. If the original number is less than 1, your exponent is going to be negative. Slide this up some. Sorry, y'all. Okay. All right. So let's do another one, okay? Using these same 4 steps, but we're going to do another problem. All right, let's slide this up some so you can see the whole thing. Okay. All right. So our next example, we're going to do. Let's do another large number. Let's do 4, 3, 8, 7, 2, 1, 6, 4. Okay. We're going to put the commas in to help us properly pronounce that or read that number. So we got 43,872,164. Your first step is to locate the decimal. If you don't see the decimal in the number, it's automatically behind that last number. Okay? You're going to move the decimal behind the first significant digit. Remember, significant digits are digits that hold value 1 through 9. So the first digit that you read in this number is the 4. That's like you're reading a book. 4 comes first. So we're going to move our decimal behind this first significant digit here, which is 4. As you're moving the decimal, count the number of spaces. 1, 2, 3, 4, 5, 6, 7. Okay? So now rewrite that number. I'm going to put a little 7 here to remind myself. All right, 4 decimal 3 8 7 2 1 6 4. Sometimes they truncate when the number's long like that. Sometimes they'll truncate the number, which means to cut a number off without rounding. Sometimes they'll use 2 or 3 numbers and they'll cut it off right in here without even rounding it, okay? And that word is called truncate, to cut a number off without rounding. So we got times 10. Okay, remember, write times 10. And the exponent will be how many times you move the decimal. You move the decimal 7 times, so your exponent is 7. If the original number is greater than 1, then the exponent is going to be a positive. If the original number is less than 1, then the exponent is going to be a negative. The original number here, this big number right here, was greater than 1, so the exponent is going to be a positive 7. And this number is written in scientific notation. Okay? Let's do another one. This time, let's make the number small. Let's make an extremely small number. We got decimal 0.0000825. Okay? This is a very small number. We're going to use the same steps. The first step is to locate the decimal. The decimal is here. The second step is to move the decimal behind the first significant digit. Significant digits are digits that hold value 1 through 9. As we read a number from left to right, the first significant digit that we come to is 8. Remember, 0 is not a significant digit. It has no value. Okay? So we're going to move this decimal behind the 8. As we're moving it, count the number of spaces. 1, 2, 3, 4, and 5. Okay? Rewrite the number. So the number is going to be 8.25. Then we write times 10 because we're moving place value, we're moving the decimal, okay? And when we, how many times did I move the decimal? Sorry, 1, 2, 3, 4, 5. That's why I wrote it the last time because, it's so easy to forget. Your exponent is going to be how many times you move that decimal, and it's 5. Okay? Now, if the original number is greater than 1, the exponent is going to be positive. If the original number is less than 1, then the exponent is going to be negative. The original number was less than 1. Look at how small this number was. So my exponent here is going to be a negative 5. Okay? When I type these numbers in the calculator, even when it's written in scientific notation, I should get the original number. Now, this one I'm going to get about the original number because remember, I took off some numbers. Okay? So this is going to be about the answer. All right? But the other ones, if I use all my numbers, I should get the exact number or the original number when I type the number in scientific notation. And I will show you that. Okay? So look. Right? If I type in this number, 8.25 times 10, and I type caret key to the negative 5, okay? Look at what I get. Oh, well, take it off. Is it on scientific? No, it's normal. Well, dag. Because that number is small, it's giving it to me in scientific notation again. The calculator's giving it to me in scientific notation. So I got to choose a number that's not as small that it can. This is a very small number. So automatically the calculator is going to write it in scientific notation because it's very small anyway. Okay. So that wasn't the best example um, there to show. Okay. Because these numbers are kind of small and some are kind of big. It's okay. It's all good to the order. All right. If you still have more questions on how to perform scientific notation, no worries. Just let me know and I can create other videos, okay? This is a skill. This is an eighth grade skill, so this skill is not going to be tested on your Math 1 exam, but it's still good to know. And I'm still putting those skills or fusing those skills into the curriculum because it's still something that you need to know. You need to know the eighth grade curriculum um, to help you be successful. And later on, you'll see these things, and you need to know what they mean when you see them in your as you travel through your mathematical career. Okay. All right. Slope. All right. Some people have asked me about slope. Okay. We hadn't gotten to slope yet, but I'm going to answer their question. The definition for slope is the steepness of a line. It's how steep the line actually is. There are 4 kinds of slope. Okay, and I'm just going to be very basic. Okay, there are 4 kinds of slope. So I'm going to draw 4 different lines. Okay, because remember, it's the steepness of a line, so I'm going to draw 4 lines. All right, you have lines, and this is of straight lines. Okay, linear lines, straight lines. You have a straight line that's going up. Since this line is going up from left to right as you're reading a book, this line is going up. From you read from left to right, this line is going up. This is a positive slope. So the answer for this slope would be a positive number. Uh, if the line from left to right, as you read it, sorry, it needs to be more of a perfect straight line. From left to right, as you read this line, the line is going down. This is a negative slope. So slope here would be a negative number. This line lays flat. There's no steepness to this line. So this line has 0 slope. Okay. There's no steepness to the line. It has 0 slope. And then this line Go straight up and down. It's impossible to walk up a line that is straight up and down. This is a vertical line. This vertical line or straight line that's going up and down has undefined slope. Okay? So, of course, vertical lines, as I said, write that out, have undefined slope. Horizontal lines have zero slope. Horizontal lines have zero slope. Lines that go from left to right go down have a negative slope, and lines that go up from left to right have a positive slope. The letter that we use for slope is M. Okay? There are two formulas for slope. One of the formulas for slope is just counting your rise over your run. How far from one point to the other is the line going up? And then how far from one point to the other is the line going from left to right? Okay? So up down is first, your y axis. Left right is second, you go left right second, your x axis. So it's rise, go up, and then over, or down and then over. Okay, rise over run. The second formula for slope is y2 minus y1 over x2 minus x1. Okay, this you use when you're given a line, and this you use when they give you just the two ordered pairs. They may tell you to find the slope of the two ordered pairs. They may say find the slope between these 2 points. Okay, this is x, this is y, this is x, this is y. This is my first point, this is my second point. And you substitute these numbers into this formula to figure out what is the slope, what is the rise over run between the 2 points. You use this formula. This formula you use when you're given a line. You pick 2 points that are on the line, like these 2 points are on the line, and you count. You know your number, your answer is going to be a negative number, but you're going to count rise over run. So your up and down is on the top. So how far do I go down to get to, let me just make, how far do I go down to get to this point? I use the grid lines, okay? So I'm going down 2 times. So my top number is a -2. Then I'm going over 2 times. So my bottom number is a +2 because I'm going to the right 2. So my slope, my answer for slope, or M, because remember that's the letter for slope, my answer for slope is going to be a -1. And so don't worry if you don't understand everything, because again, like I said, we hadn't gotten to the skill yet, but some people were asking me questions. So I wanted to go ahead and explain that. All right, y'all, have a wonderful day.